All right, today we are starting Unit 9B, Day 6, and today we're going to continue talking about solving quadratic functions using the quadratic formula, but we're also going to talk about something called the discriminant. And the discriminant can help us identify how many solutions a quadratic equation is going to have. So, let's do a quick little review here. How many solutions can a quadratic function have? This shouldn't be a surprise. This is something that we have talked about every single day. Either quadratic functions have zero solutions, one solution, or two solutions. And we've seen how this looks in a couple of different situations, whether we're graphing, so zero solutions, the parabola doesn't touch the x-axis at all. It only touches at one spot at the vertex would be one solution, or two solutions, it touches in two different spots. All right, so here's the quadratic formula. We talked about this on day 5, nothing new here. If we have a quadratic function written in standard form, then negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And if you remember, we had that catchy little video that we watched last time with the wrap. So if you need a refresher, go watch that again. Today, we're going to do a quick review, and then we're going to start talking about actually applying our discriminant. So first example, I have 4x squared plus 4x plus 0 equals negative 1. This is not yet in standard form, so we're going to first write this in standard form. So to write this in standard form, we need to have the right side equal to 0, so I'm just going to add 1 to both sides. When I add 1 to both sides, I have my new equation as 4x squared plus 4x plus 1 equals 0. I'm going to use my quadratic equation now, which means I need to know my a value, my b value, my a value, b value, and c value. A is what's in front of x squared, b is what's in front of x, c is my constant at the end. So I'm going to rewrite it using the quadratic function now. I've got negative b, so negative 4, plus or minus the square root of 4 squared minus 4 times my a value times my c value. All of this divided by 2 times a. Now this is what x equals. I'm going to go through using order of operations to simplify now. So first of all, I'm going to simplify everywhere where I'm multiplying. So that includes my exponents, because that's going to be 4 times 4. I'm going to multiply 4 times 4 times 1, and I will be subtracting that. And I've got 2 times 4 on the bottom. So simplifying in all of those spots, I've got x equals negative 4 plus or minus the square root. 4 squared is 16. Minus 4 times 1. So that's going to be minus 16. All over 2 times 4 is 8. We'll keep going through and simplifying. I'm going to simplify everything underneath the square root function. That's the only thing I can simplify in the next step here. So I have x equals negative 4 plus or minus the square root of 0 over 8. Got my plus and minus sign there. Well, square root of 0 is just 0. So now I'm left here where x equals negative 4 plus or minus 0 all divided by 8. And this is usually where we branch off and we write two different equations. And we write one equation where it's negative 4, actually, negative 4 plus 0 divided by 8 is one of our options. Or we would have the option, we'll do this one in blue, negative 4, again, negative 4 minus 0 divided by 8. And we simplify both of those to get our two different values for x. Well, hopefully you picked this up as soon as you saw 0 there, and if you didn't, that's okay. We're going to talk about that more today. Whether I'm adding 0 or subtracting 0, I'm actually getting the same thing. Both of these are going to end up being just negative 4 divided by 8. Negative 4 plus 0 is negative 4. Negative 4 minus 0 is negative 4. So either way, I'm left with my one answer, simplify 4/8 to negative 1/2. So this is an example of solving a quadratic function where we actually only have one solution. And I don't know if you've ever wondered this, but is there an easier way to tell how many solutions we're going to have for a quadratic equation without having to go through the hassle of graphing the whole thing? There actually is, and this is what we call the discriminant. So as soon as we got to point right here, where I knew that the square root of, we're going to take the square root of 0, I could tell you that we're going to just have one solution. And that's because this discriminant is what we call it, is based off of what is underneath the quadratic in our quadratic formula. It's that b squared minus 4ac. Depending on the value of that, that's going to determine how many solutions we have. If it's 0, like we saw in this last example, then it doesn't matter if we add or subtract it to our negative b term, because it's going to be the exact same thing. Versus if what's under the square root function, if instead of being 0, if it had been a positive number, if it had been 16, let's say, we'll pretend it was negative 4 plus or minus 16 instead, well, then I would have gone through and I would have had plus or minus 4, and I would have actually had to go through and think about the different examples for all of them. Fortunately, that wasn't the case, so it actually made it a lot easier on this problem. I just want to get rid of that there. Okay. So instead, when we're talking about discriminants, if you can find out that value of b squared minus 4ac underneath the square root, that alone will tell you how many solutions that we have. Because if it's 0, there's only going to be one solution. We're going to add plus 0, minus 0, divide that by 2a. Either way, there's only one option. If it's a positive number, then it's going to be the positive square root of something. Well, we can do that. We can either simplify a rational, or if it's a perfect square, we can go through and figure out what that number is, but it's either going to be a positive or a negative number. We have 2 solutions in that case. Versus if we have a negative discriminant, b squared minus 4ac ends up being a negative number, then this is going to be an example where we have 0 real solutions, because you can't take the square root of a negative number. That's how we get imaginary numbers. Don't worry, we're not going to go into that today. So 2 solutions is if the discriminant is positive, 1 solution if the discriminant is exactly 0, and if it's negative, we have 0 real solutions. Let's take a look at a couple of examples. All right, in the next 4 examples, we're not going to be looking for what x is. That's not what the discriminant tells us, but we're going to try to identify how many solutions each of the functions are going to have here. So for the first one, looking at this, in order to figure out my discriminant, I don't have to do the entire quadratic function. I only have to do the little part that's under the square root, b squared minus 4ac. So in order to do that, I still need to know what my b value is, what my a value is, and what my c value is. So the first thing is we're going to still write this in standard form. I'll add 4 to both sides, so I can get 0 off on one end by itself. So I have x squared plus 4x plus 4 equals 0. There we go. Now we've got it in standard form. My a value, well, there's nothing in front of the x, so it's just going to be 1. My b value is 4, and my c value is also 4. So for our discriminant, we've got b squared, 4 squared, minus 4 times a times c. And we're just going to simplify this. We don't need the square root for the discriminant, because we're not actually taking the square root. We just need to know if this number is going to be positive, negative, or 0. 4 squared is 16. We need to do multiplication before we can subtract. 4 times 1 times 4 is 16. Now I can subtract. 16 minus 16 is 0. So since my discriminant has a value of 0, right here, we said there's going to be 1 solution. So this problem right here, this original equation in purple right up here, the x squared plus 4x equals negative 4, will have just 1 solution. All right, take a look at the second one. Pause the video, see if you can determine how many solutions the second one is going to have, and then press play and check to see if we got the same answer. Just like last time, a equals 1, b equals this time 1, c equals 1. All 3 values are 1 this time. All right, we're going to do b squared, so 1 squared minus 4 times a, which is 1, times c, which is 1. 1 squared is 1. 4 times 1 times 1 is 4. 1 minus 4 is negative 3. So this time I have a negative value for my discriminant, which means I have no real solutions, or no solutions. you got that one too. All right, 3 and 4, same thing. Pause the video, work through number 3, work through number 4, see if you can get the same answers that I'm gonna get when I work through them. Let's change this to standard form. I'll add 16 to both sides. I'd add 16 to this side, I'd add 16 to that side. That's where that came from. There you go. A is 2, B is 12, C is 16. So to go through and actually find my discriminant, I've got 12 squared minus 4 times 2 times 16. Just substituting my values back into my discriminant. B squared minus 4 times A times C. So I've got 144 multiply, and I need to multiply here before I can subtract. So I'm going to do 4 times 2 times 16. So I've got 144 minus 128. Honestly, you don't actually have to keep going at this point because I know 144 is bigger than 128. So even if I didn't want to go through and find out that the difference of theirs 16, as long as I knew that this answer was going to be positive, I know that there is going to be 2 solutions. Not because it's specifically the number 16, but because 16 is a positive number. All right, last one here, number 4, and then we're going to take a look at some more quadratic problems, but a little bit tougher than what we were doing in our day 5 example. This one's already written in standard form. B squared, so I have 4 squared minus 4 times negative 2 times negative 3. Keep track of those negatives. A lot of times that's where I see kids making mistakes. So we have 4 squared is 16. I'm multiplying positive if I have my negative out front, but then I'm multiplying 2 negatives here. So 4 times 2 is negative 8. Negative 8 times negative 3 is a positive 24. So I'm going to leave that negative sign there. If you'd wanted to think about it as negative 4 times negative 2, that would be a positive 8. Positive 8 times negative 3 is a negative 24. So however you end up, we are going to do 16 minus 24, which is going to be a negative number. I'm not even going to do this one, 16 minus 24, because I'm trying to prove the point. I don't have to. I don't care what the value of that number is. I just need to know that it's going to be negative. And I know it's negative because I'm subtracting a larger number from a smaller number. So there are going to be no solutions here. All right. That is how you can use the discriminant to determine the number of solutions. Because maybe you don't actually care what the solutions are. Maybe you just need to know how many there are or even if there's a solution. Okay, what I have for the rest of the notes here, I have 4 examples of using the quadratic functions and simplifying quadratic functions if our discriminant is not a perfect square. So when you go through all of the work and you get to a place where your square root isn't going to be a perfect number that you can go through and just work with our integers. So that's what the next 4 examples are going to be. So I would highly encourage you at least go through 1 or 2 of these with me. If you make it to the 4th one, you might find it helpful with your homework, specifically with your second solve quadratic problems. Homework example, hint, hint, that's the exact same one that you will have in your homework assignment. So well, let's get started here. Number 1, negative x squared minus 5x minus 5 equals negative 5. Same as before, we need to rewrite this in standard form first. So different than using the discriminant, this time I'm actually solving, meaning I'm going to find the values that x can be. Negative x squared minus 5x plus 5 equals 0. In standard form now. My a value, negative 1. B value, negative 5, C value, positive 5. Let's substitute them into the quadratic formula. I have x equals negative b plus or minus the square root of b squared. Whenever I have a negative number, I like to use parentheses. Minus 4 times a times c. All of this divided by 2 times a. All right, let's move on. I'm going to go through and I'm going to highlight again all the parts that I'm going to be simplifying, which I'm going to multiply 2 times negative 1. I'm going to rewrite my double negatives as a positive. I'm going to multiply under the square root, so -5 times -5. I'm going to multiply 4 times -1 times 5. You'll see changes in all of those spots, but not combining anything yet. So we've got x equals a double negative is a positive, plus or minus the square root. Well, -5 squared is the same as -5 times -5, positive 25, minus 4 times a times c. So it depends on how you want to think about it. We could either go with 4 times -1 is a positive 4 times 5 is a positive 20, or we could think about it as 4 times -1 is a -4, -4 times 5 is a -20, and it would be a double negative here. So I'd have positive minus, or sorry, excuse me, a minus minus, which is actually going to be the same as a plus. So either way you think about it, just keep track of your negatives and make sure you're getting that sign right. All of that divided by 2 times -1, which is a -2. All right, we're just going to simplify what's under our square root. So we're going to continue simplifying here with our discriminant. That's our discriminant value. So I have x equals 5 plus or minus the square root of 25 plus 20, which is 45. All of that divided by -2. All right, now we have to actually simplify our square root right here. So we're going to simplify the square root of 45. So I'm thinking of, well, first of all, is 45 a perfect square? Go through your list. It is not. Okay, so now we have to go through and think, what is a perfect square that goes into 45? And we're going to simplify that. So I'm going to do this over here. Square root of 45. Well, that equals 9 times 5. 9 is a perfect square, so I can do the square root of 9 times the square root of 5, which if I simplify that equals 3 the square root of 5. Square root of 9 is 3. Square root of 5, we can't simplify that any further. So if I go down on my list here, I've got x equals 5 plus or minus 3 the square root of 5. That's what 45 is. All of that divided by -2. Now, looking at this looks a little bit messier here, and typically we would branch this into 2 different problems, right? At this point, I would go from here and I would have option 1 being 5 plus 3 the square root of 5 all over -2. That would be one option. And then I would have 5 minus 3 the square root of 5 all over -2. That's usually what we would do, but when I'm looking at this still looks pretty messy because I can't go through and add or divide or multiply or subtract anything in this case because technically 5 and 3 times the square root of 5, they are not like terms, which means I cannot combine those two. I cannot add them together. Now I'm looking to see if I can divide. Can I simplify this and use up that -2 anywhere? Well, I have to check to see if -2 is a factor of either 5 or 3 times the square root of 5. Another way to think about this would be writing it as 5 divided by -2 plus 3 the square root of 5 divided by -2. I'm dividing the whole thing by -2. Each term is being divided by -2. I'm looking to see if I can simplify that. Is there something that goes into both the top and the bottom? And in this case, there isn't. So I have actually already gotten this completely in standard form when I got to my answer right here. I need to go through and check to see if I can simplify it, if I can write it in a nicer way or clean it up at all. But I have to be careful to make sure I'm not going out of the order of operations. I can't add before I multiply. And if I'm dividing, I have to make sure that I'm dividing all the terms by -2, not just one of the terms. Otherwise, it's no longer equal to its original value. So what I have circled right here, this would actually be your final answer. That's how you would type it in. Not the prettiest looking answer, but it's still going to be a number. That right there is a number. It's just not a perfect number. It's going to be a repeating decimal that will continuously go and go and go. So this is representing as an exact answer without having to round the decimal. All right, we have three more. Next one, x squared plus 2x equals 21. Let's go ahead and write this in standard form by subtracting 21 from both sides. There we go. My a value is 1, my b value is 2, my c value is negative 21. I'm going to go through this one a little bit faster here. If you need to, pause it and re-look at where I'm going for each of my steps. My b value, so I've got negative b plus or minus the square root of b squared minus 4 times 1 times negative 21. All of that divided by 2 times a, 2 times 1. Simplifying, I'm going to simplify the same stuff that I did last time. I don't have double negatives to simplify this time, but I will rewrite it as negative 2 plus or minus the square root of 2 squared, which is 4. And I know I've got it, 4 times 1 is 4, 4 times 21 is 84. So I've got minus a negative 84 or plus 84, all divided by 2 times 1, which is just 2. Continuing on here, got negative 2 plus or minus the square root of 4 plus 84, which is 8, all divided by 2. Well, now I've got to look and see, can I simplify the square root of 88? So think about what is a perfect square that goes into 88. The first one that jumped out to me would be a 4. So I've got the square root of 4 times the square root of 22. 2 times 20, 4 times 22 is 88. I can simplify this to be 2 the square root of 22. So I will rewrite my problem now using 2 the square root of 22 instead of the square root of 88. So I have negative 2 plus or minus 2 the square root of 22 all divided by 2. Now, same idea as last one. Now, this time I can't add negative 2 plus or minus 2 the square root of 22. I can't add it, I can't subtract it because I'm multiplying by the square root of 22. So I cannot combine those two things. They are not like terms. However, I'm going to check again to see if I have something that I can simplify, that I can clean this up a little bit, just like you would simplify a fraction. Do I have the same thing as the top as the bottom? And the way I like to think about this, remember, this it's not just dividing negative 2 by 2. It's not dividing 2 to the square root of 2 by 22. It's dividing every term we have on the top by 2. So we can rewrite this and think about this as negative 2 over 2 plus or minus 2 the square root of 22 all divided by 2. So all I'm doing is I'm rewriting it into two different parts, just like two fractions. So now looking at this, if I have negative 2 over 2, how would you simplify that? Well, negative 2 over 2, or negative 2 divided by 2, is negative 1. Plus or minus. Over here, now I can't divide the square root of 22 by 2, but I have a 2 that's being multiplied there. So I can actually divide 2 by 2. 2 divided by 2 is 1. So I'm left with 1 the square root of 22, which is actually just the square root of 122. A little bit cleaner than our last answer. We still have that plus or minus in there, but that's how I'd actually take it and write it in simplest form now. Cleaning it up a little bit. All right, we have 2 left. 4x squared plus 24 plus 16 equals 0. This time they left it in standard form for us. That was nice of them. A is 4, B is 24, C is 16. All right, let's take a look. So we have x equals negative b plus or minus the square root of b squared, this is going to be a big number there, minus 4 times a times c, all divided by 2 times 4. Same thing as last time. At any point I start going too fast, pause it, slow it down, rewatch it. It's okay. It's your video. You can do what you want with it. All right, so then simplifying. Negative 24 is going to stay the same, plus or minus. Well, 24 squared is 576. 4 times 4 times 16 I'm going to be subtracting 256. And all of that is going to be divided by 2 times 4, which is 8. All right, so we have x equals negative 24. Nothing's changed there yet. Plus or minus the square root. 576 minus 256 is 320. All of that divided by 8. Now is where I go to see if I can simplify 320. So we're starting to look and say, well, what is a perfect square that goes into 320? So I would go through, start at your list, start going through them, multiplying them out. Let's start with, does 100 go into 320? 32 times? Sorry, not 100. 10 goes into it. That's not a perfect square. So 10 doesn't. Let's go. 300 or 100 doesn't. So does 81 go into it? 81. 320 divided by 81. Doesn't work out. Okay, what about, that was 8 squared, 7, that was 9 squared, 8 squared. Does 320 divide by 64? Hey, it does. Does not work out. So the square root of 320 can be broken into the square root of 8 squared, which is 64, times the square root of 5. So the square root of 320 is actually 8, the square root of 5. So we can rewrite that now. There we go. X equals negative 24 plus or minus 8, the square root of 5, all over 8. Let's see if we can split this up and if we can simplify this any further. So I'm going to break this into my two fractions. I have negative 24 divided by 8. Well, I know 8 goes into 24, plus 8, the square root of 5 divided by 8, plus or minus. So it looks like we can simplify this as negative 24 divided by 8 is 3, negative 3, plus or minus, well, I have an 8 right here, I have an 8 right here, so those two can cancel out. So we've got the square root of 5. X equals negative 3 plus or minus the square root of 5. There you go. Last one for today, and then you can start working on your homework. 3x squared minus 6x plus 2 equals 3. Not in standard form yet, but we can change that pretty quickly by subtracting 3 from both sides. So in standard form, I have 3x squared minus 6x minus 1 equals 0. My a term is 3, my b term is negative 6, and my c term is negative 1. Writing this out using quadratic formula, have negative b, so negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 1. All of that divided by 2 times 3, 2 times a. All right, let's simplify. I'm going to simplify my double negative. Negative 6 is a positive 6, plus or minus the square root. Negative 6 squared is positive 36. Minus 4 times 3 is 12. 12 times negative 1 is a negative 1. So if I'm subtracting that, it's going to be plus 12. All of this divided by 2 times 3, which is 6. All right. So I have x equals, try to switch colors there, x equals 6 plus or minus the square root of 36 plus 12, which is 48, divided by 6. All right, what is a square root? What is this? Square root of 48 simplified. Is there a perfect square that goes into 48? Yes, there is. And if you stuck with 4, yes, you would be able to go with 4, but you'd have to simplify that a couple times. I think there's actually one that's bigger than that. I believe it is square root of 48 equals the square root of 16 times the square root of 3. It will eventually save you time to start bigger and actually check some of those larger factors of 48, larger perfect factors. So starting, what's the smallest perfect square number that's below 48? So 49 can't go into 48 because 49 is bigger than 48. So that was 7 squared. So go down to 6 squared. Does 36 go into 48? No. Does 5 squared, 25 go into 48? Nope. So then go down. Does 4 squared go into 48? 16 goes into 48 3 times. So I can simplify this as 4 to the square root of 3. All right, so we have x equals 6 plus or minus 4 to the square root of 3 all over 6. Let's simplify this and see if we can clean this up at all. We have 6 plus or minus, well, 6 over 6 plus or minus 4 to the square root of 3 over 6. Just breaking that into the two fractions it's being divided by. Simplify this. 6 over 6. Well, that's just equal to, this in red, 1 plus or minus. Well, what goes into both 6 and 4? 2 does. 2 goes into 4 2 times. 2 goes into 6 3 times. So then I have 1 plus or minus 2 square root of 3 all over 3, just like that. There you go. Clean it up a little bit, just a little bit, not a lot, but there it is. All right. Final answer. One other way that you could have done this, if we had left this as the original of 6 plus or minus 4 to the square root of 3, right there, right? You could look to see, does 6 go into, what numbers go into 6, 6, and 4? If we had done that, it's going to look a little bit different because we wouldn't be able to go through and, hang on, sorry. Oh yeah, we're good. So since 6 doesn't go into all 3 of these terms, we have to be a little bit more careful. So let me zoom in a little bit so we can see this a little bit better. Okay, we're focusing in right here. If I had wanted to simplify this as it was without breaking it up into two different spots, we can do that. You just got to be careful to make sure that whatever you're breaking down, whatever you're simplifying with, has to go into all 3 terms, not just one of the terms. It has to go into all 3 terms. So there is a number that goes into 6, 6, and 4, but it's not 6. 6 doesn't go into 4, right? So we could actually go through and we could divide each of these terms by 2, because 2 goes into all of them, but we can't divide it all by 6. So another way that we could write it, we have our answer in red. Another way that we could have written this to simplify it, you might see it written this way, would instead of 6 or 1 plus or minus 2 to the square root of 3 all over 3, like we have right there in red. The other option would be, well, 2 goes into 6 3 times, 2 goes into 6 3 times, 2 goes into 4 2 times. So you also could see this one written as x equals 3 plus or minus 2 the square root of 3 all divided by 3, which is actually equivalent. These two things are the same thing. What we have there, both are valid answers. And if I had rewritten what I have here in green and broke it up like I had done originally right below that blue there, we would be rewriting it like this. Technically, most of the time, since either answer is correct, most of the time you will see it written more in the form of what we have in the green up there. But either of those technically should be correct, as they are equivalent and written in simplest form. Okay, that's what you guys have. That is Unit 9B, Day 6 notes. We talked about using the discriminant to identify how many solutions a quadratic function is going to have. And then we went through and we looked at a couple examples of quadratic functions when you do not have a nice perfect square as your discriminant. So go ahead, work through your questions for your day today on your homework. Make sure you're getting your days 1 through 5 homework done as well. And if you have any questions, please make sure that you are reaching out to your intermediate algebra teacher. All right, guys, have a wonderful day.